Hi everyone, and welcome to my channel. Today, we're diving into the future of warfare, moving from missiles to lasers with Israel's groundbreaking Iron Beam defense system. You've probably heard of the Iron Dome, which shoots down rockets with interceptor missiles. But what if you could do the same job, but with a beam of pure energy? That's exactly what the Iron Beam is all about. So what is the Iron Beam? It's a directed energy weapon, or DW for short. Specifically, it's a high-energy laser weapon system designed to destroy short-range threats in the air. Instead of firing a physical missile, it focuses a powerful laser beam onto a target, heating it up so rapidly that it's destroyed in midair, usually within just 4 to 5 seconds of the beam making contact. Think of it as a super-powered magnifying glass, but instead of ants, it's taking out rockets and drones. This revolutionary system was developed by the Israeli defense contractor Rafael Advanced Defense Systems, the same company behind the famous Iron Dome. Development has been ongoing for over a decade, with the Israeli government pouring significant investment into fast-tracking its deployment. The primary motivation behind its creation is simple: cost. Let's talk about why it was developed. Israel's Iron Dome has been incredibly effective, boasting a success rate of over 90%. However, this success comes at a steep price. Each Tamir interceptor missile used by the Iron Dome costs anywhere from $40,000 to $100,000. Now, imagine you're using one of these expensive missiles to shoot down a crude, homemade rocket that might have only cost a few $100s to build. The economics just don't add up. Your enemy can launch dozens of cheap rockets, forcing you to spend millions on defense in just a few minutes. This economic imbalance is a huge strategic vulnerability. This is where the Iron Beam changes the game entirely. Once the system is installed and powered, the cost per shot is astonishingly low. Israeli officials have stated that each interception costs only a few dollars, maybe even as low as $2. This figure primarily covers the cost of the electricity needed to generate the laser pulse. You go from spending $50,000 per interception to spending less than the price of a cup of coffee. This completely flips the economic equation of aerial defense, making it sustainable to counter swarms of cheap threats. Now, let's break down the main parts of the Iron Beam system. It's not just a single giant laser cannon. A typical Iron Beam battery consists of several key components working together seamlessly. First, you have the radar system. This acts as the eyes of the system, detecting and tracking incoming threats like rockets, mortars, or drones. Next is the command and control unit, which is the brain. It analyzes the data from the radar, assesses the threat level, and makes the decision to engage. Finally, you have the laser effector itself. This is the part that generates and fires the high-energy laser beam. These units are designed to be mobile, often mounted on trucks, allowing them to be deployed wherever they are needed most to protect military bases, critical infrastructure, or civilian areas. One of the biggest questions about any laser weapon is its power. How much energy does it actually use? The Iron Beam's laser is reported to have a power output of around 100 to 150 kilowatts. To put that in perspective, a standard microwave oven uses about 1 kilowatt. So, we're talking about a beam with the power of over 100 microwaves focused on a single point the size of a coin. This intense concentration of energy is what allows it to heat up and destroy a target so quickly. This power level is what's needed to be effective against the fast-moving, small targets it's designed to intercept. So, what can the Iron Beam actually hit? Its primary targets are what military planners call short-range threats. This includes things like Qassam-style rockets, which are unguided and have a relatively short flight time. It's also highly effective against mortar shells, which are notoriously difficult to intercept with traditional systems due to their high-arcing trajectory. And perhaps most importantly in modern warfare, it's designed to counter small, unmanned aerial vehicles, or drones. Drones have become a cheap and widespread threat, used for both surveillance and attacks, and the Iron Beam offers a cost-effective way to neutralize them in large numbers. As for its maximum range, the Iron Beam is designed for point defense, meaning it protects a specific, localized area. While exact figures are classified, its effective range is reported to be up to about 7 kilometers, or roughly 4.5 miles. This is shorter than the Iron Dome, which can engage targets up to 70 kilometers away, but that's by design. The Iron Beam isn't meant to replace the Iron Dome, it's meant to complement it. It handles the very close-range threats, freeing up the more expensive Iron Dome interceptors for longer-range, more sophisticated targets. It's all about creating a multi-layered defense system where each layer is optimized for a specific type of threat and cost efficiency. There's been a lot of news about the Iron Beam recently. In April 2022, Israel's Ministry of Defense released dramatic footage of a successful test, showing the laser system effortlessly intercepting a rocket, a mortar shell, and a drone. It was a major milestone that proved the concept was viable in the real world. Then, following the attacks on October 7, 2023, there were reports that Israel was accelerating the deployment of the Iron Beam to the Gaza border. While its operational status is still being ramped up, Prime Minister Benjamin Netanyahu confirmed in late 2023 that the system had been deployed for the first time. The goal is to integrate it fully with the Iron Dome, creating a more robust and economically sustainable air defense network. Now, how does the Iron Beam stack up against other directed energy weapons being developed around the world? Several major powers are in this race. The United States has multiple programs. The U.S. Navy has the Laser Weapon System, or LAWS, which was deployed on the USS Ponce and has a power of about 30 kilowatts. They also have a more powerful system called Helios with a 60 kilowatt laser, which is being installed on destroyers. The U.S. Army is working on a truck-mounted 300 kilowatt laser as part of its Indirect Fire Protection Capability program. These systems are powerful, but are mostly focused on naval or ground vehicle applications. The United Kingdom has its Dragon Fire laser, a 50 kilowatt system, which was recently tested successfully against aerial targets. Like the Iron Beam, its main selling point is the extremely low cost per shot, estimated at less than 10 pounds, or about $13. China is also a major player, though information is more secretive. They are known to be developing a system called the Silent Hunter, which was displayed at an arms fair and is claimed to have a power of around 30 to 100 kilowatts with a range of up to 4 kilometers. When you compare them, the Iron Beam's 100 plus kilowatt power and 7 kilometer range put it at the forefront of currently deployable tactical laser weapons. While the US is aiming for higher power levels in the future, Israel's Iron Beam appears to be one of the first systems to move from the testing phase to actual operational deployment in a conflict zone. The Iron Beam represents a true paradigm shift in military technology. It's not science fiction anymore. It's a reality on the battlefield. By turning the tables on the economics of warfare, it provides a sustainable solution to the persistent threat of cheap, short-range attacks. As this technology matures and becomes more powerful, laser weapons are set to play an increasingly crucial role in defending skies around the world. Thank you so much for watching. I hope you found this deep dive into the Iron Beam interesting. If you enjoyed the video, please give it a thumbs up and consider subscribing for more content on the latest in technology and defense.